Welcome back to the deep dive. You know, when you send in your request to learn more about the Parker Solar Probe, I have to admit, I was a little intimidated.
Oh, yeah.
I mean, touching the sun. That sounds like something out of Greek mythology, not real-life science.
It does have a mythical quality to it, doesn't it? But the Parker Solar Probe is very real, and it's sending back data that's already changing how we understand our nearest star.
Exactly. And it's not just about gathering cool facts, it's about understanding things that could directly impact us here on Earth.
Right.
So let's unpack this together.
Okay.
We've got a stack of articles and videos you provided, all about this audacious mission to get closer to the sun than any spacecraft before.
What's fascinating is that we're talking about a mission that's pushing the very limits of what's technologically possible. Just consider this. The probe is traveling at speeds exceeding 430,000 miles per hour.
Wow.
To put that into perspective, it could cross the entire continental United States in about a minute.
It's mind-boggling. And it needs that kind of speed to not only escape Earth's gravity, but also to get close to the sun and then slingshot back out again.
Right.
It's a cosmic dance, really, and one that's carefully choreographed to ensure the probe doesn't get fried by the sun's intense heat.
It's truly a marvel of engineering. And to think this mission was first conceptualized back in the 1950s, but it took decades of technological advancements to make it a reality.
That's a testament to human persistence and ingenuity.
Yeah.
But let's get to the heart of it. Why send a probe this close to the sun in the first place?
Well, the sun is much more than just a source of light and warmth. It's a dynamic and complex object that constantly throws energy and particles our way. This solar wind, as it's called, can have a profound impact on Earth.
Right, we hear about solar flares and solar storms that can disrupt satellites and even cause power outages here on Earth.
Yeah.
It's a reminder that even though the sun seems so distant, it's intimately connected to our lives.
Precisely. And the truth is, we still have so much to learn about how the sun works. For example, one of the biggest mysteries is why the sun's outer atmosphere, the corona, is millions of degrees hotter than its surface. It defies logic.
It's like stepping away from a campfire and suddenly feeling 1,000 times hotter. Scientists call this the coronal heating problem, and it's been baffling them for decades.
And it's not just the heat. We also don't fully understand how the solar wind accelerates to such incredible speeds or how solar flares are triggered. These are fundamental questions about the star that sustains life on our planet.
Okay, so we've established that there are a lot of unanswered questions about the sun, and some of those questions have serious implications for us here on Earth. So how does the Parker Solar Probe fit into all of this?
The Parker Solar Probe is designed to gather data from within the sun's atmosphere from a region we've never been able to study before. It's giving us a close-up look at the processes that drive the solar wind and shape space weather.
It's literally flying through the region where these solar mysteries originate. And in doing so, it's not just collecting data, it's changing our very understanding of how the sun works.
Welcome back to our deep dive into the Parker Solar Probe. You know, one of the most exciting aspects of this mission is the way it's challenging our preconceived notions.
I'm all ears. Give me an example.
We'll take the solar wind. We used to think of it as a relatively uniform stream of particles flowing outward from the sun.
Right, kind of like a steady breeze.
Exactly. But the Parker Solar Probe is showing us that it's far more complex and turbulent than that. Imagine a river, not a gentle stream, but a raging torrent with swirling eddies, unexpected currents, and even rogue waves. That's a closer analogy to what the probe is encountering.
Wow. So it's not just a constant stream, but a dynamic and ever-changing flow. What does that mean for us here on Earth?
It means that predicting space weather is far more challenging than we initially thought. Those swirling eddies and rogue waves in the solar wind can translate into sudden bursts of energy that can disrupt our satellites and even impact our power grids here on Earth.
So the stakes are pretty high for understanding these solar wind dynamics. What specifically is the Parker Solar Probe revealing about these rogue waves, as you call them?
One of the most significant discoveries has been the detection of what scientists are calling swishbacks. These are sudden, dramatic reversals in the magnetic field of the solar wind, kind of like the solar wind is doing a U-turn.
Okay, that sounds pretty intense. Are we talking about massive shifts that happen gradually, or are these rapid changes?
They happen quickly over the course of just a few seconds sometimes. Imagine you're sailing on a calm sea, and suddenly a giant wave rises up in front of you, seemingly out of nowhere. That's the kind of unexpected behavior the probe is observing.
That paints quite a picture. What's the thinking on what causes these sudden switchbacks? Is this a case of solar indigestion or something more complex?
Well, there are a few leading theories. Some scientists believe that switchbacks originate near the surface of the sun, where the magnetic field is highly complex and dynamic. Imagine a giant ball of tangled magnetic spaghetti. As these magnetic fields interact and reconnect, they could be launching bursts of energy and particles into the solar wind, creating these switchbacks.
So it's like the sun's constantly rearranging its magnetic furniture, and the Parker Solar Probe is catching it in the act.
That's a great analogy. Another theory is that switchbacks are caused by interactions between different streams of the solar wind. As these streams collide, they create shock waves and turbulence, which could also explain these sudden magnetic reversals.
It sounds like we're piecing together a new understanding of the solar wind,
Yeah.
one that's far more dynamic and unpredictable than we previously imagined. But we talked earlier about the coronal heating problem, the mystery of why the sun's outer atmosphere is so much hotter than its surface. Is the Parker Solar Probe shedding any light on that as well?
It is. The probe's instruments are detecting a phenomenon that could be a key piece of the puzzle. Alphen waves. These are magnetic waves that propagate through the sun's atmosphere, and they appear to be carrying vast amounts of energy outward from the sun's interior.
Okay, so imagine these Alphen waves as being like surfers riding the waves of the sun's magnetic field.
That's a pretty good image. As these waves travel outwards, they interact with the particles in the corona, transferring energy to them and causing them to heat up.
So these waves are like tiny little delivery trucks bringing heat from the sun's core out to the corona.
Exactly. And the Parker Solar Probe is measuring the properties of these waves and how they interact with the solar wind. This data is giving us unprecedented insights into the mechanisms that drive coronal heating.
So we're getting a much more nuanced picture of the sun's magnetic field, its impact on the solar wind, and even how it heats its outer atmosphere. It sounds like this mission is rewriting the textbooks on solar physics.
It is. And keep in mind, the Parker Solar Probe is still on its mission. With each close approach to the sun, we're gathering more data and gaining a deeper understanding of our nearest star.
This is where it gets really interesting because, as you mentioned earlier, understanding the sun isn't just about scientific curiosity. It's also about understanding how these solar phenomena impact us here on Earth.
Absolutely. What we're learning about the solar wind space, weather, and the sun's magnetic field has direct implications for our technological infrastructure, our astronauts, and even our daily lives. And that's what we'll be exploring in the final part of our deep dive.
Welcome back to the Deep Dive. We've been on quite a journey, haven't we?
Have.
From mind-boggling speeds to tangled magnetic fields and rogue waves in the solar wind, it's been a wild ride.
It has been a fascinating exploration, hasn't it? And as we wrap up this deep dive into the Parker Solar Probe, it's worth emphasizing that all of this incredible science has real-world implications.
Okay, so let's bring it home for our listeners. You mentioned earlier that understanding the sun isn't just about satisfying our scientific curiosity. It's about protecting ourselves right.
Precisely. Think about how much we rely on technology that's vulnerable to space weather. Satellites, power grids, communication networks, they can all be disrupted by solar storms.
It's like we've built this incredible technological civilization, but we've forgotten that we're still at the mercy of a star that can throw a cosmic tantrum at any moment.
That's a great way to put it. And the more we rely on space-based technology, the higher the stakes become. Imagine widespread GPS outages, disrupted financial transactions, or even large-scale power blackouts caused by a major solar storm.
Yeah, it's a sobering thought.
It is.
It makes you realize how interconnected everything is. But that's where the Parker Solar Probe comes in, right? By understanding the sun better, we can better predict these events and take steps to protect ourselves.
Exactly. The data the probe is gathering is helping us develop more accurate space weather forecasts. It's like having a storm warning system, but for solar storms instead of hurricanes.
Okay, so walk me through this. Let's say we get a solar storm warning, thanks to the Parker Solar Probe's data. What kinds of protective measures are we talking about?
Well, for satellites, we can put them into safe mode, essentially powering down sensitive systems until the storm passes. For power grids, we can adjust load distribution to minimize the risk of blackouts. And for astronauts on missions beyond Earth's magnetic field, we can give them timely warnings to seek shelter.
So it's a combination of proactive measures and quick reactions, all based on a deeper understanding of how the sun behaves.
Precisely. The Parker Solar Probe is giving us the knowledge we need to move from a reactive approach to space weather to a more proactive one.
That's a game changer, isn't it? It's like we're learning to speak the sun's language and anticipate its moods.
It's a bit like that, yes.
Yep.
And the implications go beyond just protecting our technology. As we venture further into space with missions to the moon, Mars, and beyond, understanding space weather becomes even more critical.
It's like we're packing for a long journey, and the Parker Solar Probe is helping us make sure we have the right gear to weather any cosmic storms along the way.
That's a great analogy. And beyond the practical applications, there's something truly inspiring about this mission.
I agree. What stands out to you?
It's a testament to human ingenuity, our insatiable curiosity, and our desire to explore the unknown. It's a reminder that even in the age of artificial intelligence and virtual reality, there's still a place for bold exploration and the thrill of scientific discovery.
Well said. And I think that's a perfect note to end on. So, listener, we hope this deep dive into the Parker Solar Probe has ignited your curiosity about our nearest star.
It's a story that's still unfolding with new discoveries and insights emerging all the time. Who knows what other secrets the sun holds just waiting to be unlocked?
That's a great question to leave our listeners pondering. Until next time, keep exploring and never stop asking questions.
Please like this video and subscribe to our channel. For more detail, you can visit our blog website www.evergreentechtips.com.